Section 4.1 is entitled An Introduction to Factoring. So before we get started with this, let's just have a quick review of what factoring is and what is meant by factors. Factors are numbers that you multiply together to get a product. So let's say that you were asked to find the factors of the number 16. What numbers can you multiply together to get 16? Well, you could multiply 1 times 16. You could multiply 2 times 8. You could multiply 4 times 4. So those are all the factors of the number 16. If you were asked to give all the factors of 24, what numbers can you multiply together to get 24? There are a lot of them. 1 times 24 would work. 2 times 12 are factors of 24. 3 times 8 are factors of 24, and 4 times 6 are factors of 24. So there are a lot of factors for 24. Remember, there are some numbers that only have 2 factors. 37 is an example. 37 is a prime number. It has exactly 2 factors, 1 times 37. So, one of the things with this particular section is just remembering what we mean by the word factors. One other idea to review is what is meant by the greatest common factor, also known as the GCF. A few moments ago we talked about the factors of 16, and we had said that the factors of 16 were 1, 2, 4, 8, and 16. We had said that the factors of 24 a few moments ago were 1, 2, 3, 4, 6, 8, 12, and 24. When we talk about the greatest common factor, we are talking about what factor is in both lists and is the greatest number, and that would be 8. So the greatest common factor of 16 and 24 is equal to 8. Notice that 16 and 24 have other factors other than just 8. They also have 4 as factors, they also have 2 as factors, and they also have 1 as factors. But the greatest common factor is 8. So let's turn our attention to factors with algebra. What are all the factors of a to the 5th power? Well, a to the 5th power means a times a times a times a times a. So each one of those is a factor of a to the 5th power. But, of course, if we wanted to, we could combine a few of these. We could say we just have a times a to the 4th. So, a is a factor of a to the 5th. A to the 4th is also a factor of a to the 5th. We could also say that we have a squared times a to the 3rd power. So a to the 2nd power times a to the 3rd power, those are also factors of a to the 5th. There are all sorts of different factors, all sorts of different ways that we could actually write this. We could write it also as a to the 3rd times a squared. We could write it as a to the 3rd times a times a. There are all sorts of ways of writing all the factors of a to the 5th. So let's combine both of these ideas then into one. What are all the factors of 5a to the 3rd power? We could say 5a to the 3rd power is 5 times a times a times a. We could also say it's 5 times a squared, or we could just say it's 5 times a to the 3rd. Being able to write these as separate factors is going to be important in this particular section. We talked about the greatest common factor when just dealing with numbers. Let's talk about the greatest common factor when dealing with algebra. If you have 8 to the 5th and 5a to the 3rd, and I want to know what is the greatest common factor of those, well, 8 to the 5th, the factors, if I once again wrote them out, a times a times a times a, 5a to the 3rd, the common factor, the factors would be 5 times a times a times a. Well, what's common in both of those? They both have 3 of these a's that are the same. So the greatest common factor of these two is just a to the 3rd. Here's one more example. What is the GCF of these 3 different algebraic expressions? The first one I have is 15ab to the 3rd. So if I was going to factor that, I could say that's 3 times 5 times a times b times b times b. If I factor the second algebraic expression, 10a squared b squared c, I could say that's 2 times 5 times a times a times b times b times c. The third one, 25b squared c to the 3rd power, 5 times 5 times b times b times c times c times c. So now I'm trying to find what is the greatest common factor. Well, they all have a common factor of 5. So I'm going to circle my 5, and that's one of them. They also have some b's. Notice this one has a b, this one has a b, this one has a b, but they also have another b. This one has a b, this one has a b, this one has a b. The last one right here does not have any a's in it, so I cannot use a as a common factor. The first one does not have any c's in it, so I can't use c. So the greatest common factor of these 3 different algebraic expressions is just 5b squared, because I would do the b and the b together and get my b squared. What you really need to be able to do in this section is to go through and factor different types of binomials and polynomials. But before factoring those, let's just review one thing on using the distributive property. If you have the expression 4 times x plus 8, and you wanted to write that without parentheses, remember that you can always go through and use the distributive property, multiply 4 times the first term inside the set parentheses, and also multiply 4 times the second term in the set parentheses, so you get 4x plus 32. If you had 5 times x minus 4, we would go through and do the same thing, and we would get 5x minus 20. One more example. If we had 2x on the outside and inside the set parentheses x subtract 6, we could go through and multiply. We would use the distributive property, multiply 2x times x and get 2x squared, and then multiply 2x minus 6 and get minus 12x. Well, each one of these answers is really a binomial. So what we're going to do is we are going to do the opposite of what we just did. We are going to factor those out. So if you have 4x plus 32 and you want to factor that, there is a common 4 in both of those terms. So I could factor out a 4, and I would be left with 4 times, in parentheses, x plus 8, which is what I started with right up here. If I did the same thing with the next one, 5x minus 20, I'm looking for what is a common factor in both of those terms. The common factor in both of those terms is a 5. I could factor out a 5. I would be left with x minus 4. And then finally, the last one, 2x squared minus 12x. I need to think, what is the common factor in the 2x squared and the 12x? They have a common factor of 2x. And what's left is just that x minus 6. And you can see that, once again, all of these answers that I have are exactly what I started with. So all we're doing is we are doing the reverse of the distributive property. Here are a couple more examples. The first one I have, 15a cubed minus 25a squared. I am taking a look at both of those terms, and I am trying to figure out what's common. Well, in 15, 8 cubed and 25a squared, in just the numbers themselves, I have a common factor of 5, so I can take a 5 out. As far as the a cubed and the a squared, I have a common factor of a squared, so I can take an a squared out. So then I just need to go through and figure out, well, what do I have left? If I take a 5a squared out of that 15a cubed, it's in a way I'm kind of dividing that 5a squared by that 15a cubed divided by 5a squared, so I am left with just 3a. If I take a 5a squared out of that 25a squared, then I'm just left with 5. So, if I want to go through and factor, I have 5a squared times, in parentheses, 3a minus 5. In the second example, 36b to the fourth plus 24b squared, first of all, I'm just going to take a look at my numbers. I have a 36 and a 24, and a common factor of 36 and 24 is 12. Then I'm going to take a look at my algebraic expressions that I have there, just the b to the fourth and b squared. The common factor between both of those is b squared. So now I just need to figure out what do I have left. Once again, one way to do this is I'm really dividing both of these terms by that common factor. If I divide 36b to the fourth divided by 12b squared, 36 divided by 12 gives me 3. B to the fourth divided by b squared gives me a b squared. If I do the same thing with the second term, if I divide that by b squared, 12b squared, 24 divided by 12 gives me 2, and b squared divided by b squared cancels, so I am just left with, inside the set parentheses, 3b squared plus 2. Up to this point, we've been doing factoring with just binomials, that is, two different terms. This time I have polynomial factoring, which has 3 different terms. In the very first one, you can see that I have a 6, a 9, and a 12. And the common factor of 6, 9, and 12 is 3. So I could factor a 3 out of all those. Then, when I take a look at the variables, I have an m, an mn, and an mn squared. The common factor of those variables is just an m. So I could factor an m out of all 3 of those. If I factor a 3m out of each one of those terms, I'm going to write it for this one again. I'm just going to divide each of them by 3m. For the very first term, I'm left with a 2. If I factor a 3m out of that second term, I am left with a 3n. And if I factor a 3m out of that third term, I'm left with a 4n squared. So, factoring that particular polynomial gives me this for my answer. As far as the second one goes, I'm not going to go through and do the division each time. I'll just talk it through. Once again, I'm taking a look at my numbers. I have a 4, a 6, and a 14. The common factor is 2, so I could factor a 2 out of those. As far as the variables, I have an s, an st, and an st squared. I can only factor out an s. So now I need to just figure out, well, what do I have left? When I factor a 2s out of the 4s, I'm left with a 2. When I factor a 2s out of the 6st, I'm left with a 3t. And when I factor a 2s out of the 14st squared, I'm left with minus 7t squared. The last one that I have here is just a little bit different. Oops, I see I did forget to put a little squared here. This should be negative 4x squared. As far as this one goes, I see that I have a common factor with my numbers of a 4. But I'm going to be taking out, for this particular one, a negative 4, because I don't like that negative sign in front. You don't have to do this, but you will often want to do this. So I'm going to factor out actually a negative 4. I can't factor out anything else out of that because this particular term right here does not have an x variable with it. So all I can factor out is the negative 4. If I factor a negative 4 out of that first term, I'm left with x squared. If I factor a negative 4 out of the subtract 16x, remember that that becomes plus 14x, or plus 4x, I'm sorry. And then when I factor a negative 4 out of the plus 4, I'm left with subtract 1. So this factors out to negative 4 and then in parentheses x squared plus 4x subtract 1. Don't let this negative 4 sign, factoring this out, cause you problems when you go through and you factor it out. Remember that negative 4, when I multiply that through, I'd multiply negative 4 times this, which would give me the negative 16x, which is what I started with. This video is already pretty long, so I'm going to stop here, but there is more to talk about. So please take a look for the section that's entitled Section 4.1, Part 2, and I will continue.